Hi everyone. This is a look at selective precipitation. Selective precipitation is a style of problem where we have a mixture of cations given to us. Typically it's going to be three. Here's an example with silver, lead 2 ions, and thallium ions. A mixture of three cations most of the time. They're given to us and the idea is we want to precipitate them out one at a time. Individually one at a time. To do that, we're going to rely heavily on the solubility chart on page 3 of the data booklet. Importantly, once a cation is precipitated, it's considered removed. It's exited from the question. And the number of steps to our answer is going to correspond to the number of cations. Most questions are going to give us 3 cations, so most questions will have a 3-part answer. What we want to do is imagine we have a fully stocked lab. Any chemical imaginable we have at our disposal. We're going to use the solubility chart to find something across the top that makes one of the 3 ions here precipitate. It doesn't matter which one. The order is not specific. We just want to get one. I want to find a chemical across the top of the solubility chart that makes one of the 3 turn solid. Just a reminder that it's the second row. It's the bottom half of the solubility chart where here it says slightly soluble. That's the solid part. And we just want to check. Here on the right hand side, we have hydroxide ions. That would be a bad choice because all 3 would turn solid. That's no good. I want just one out of the 3. In the next column over, it's iodate and oxalate. Again, that would be a bad choice. All 3 would precipitate. The next column over has carbonate, phosphate, and sulfite ions. Again, all 3 would turn solid. That's a bad choice. With SO4, it's a better choice, but we still have the silver and the lead. We get 2 of the 3. That's no good. We want just one of the 3. Find a chemical across the top that makes one of the 3 turn solid. Here, if I look at the fluoride ion column, the F- column, we see that in the bottom half, what's listed down here is lead 2 ions are going to turn solid, but silver ions or the thallium is not specifically listed. So that's a good choice. So I'm going to add F-, add fluoride ions. And how did I know that? It was my choice using the solubility table. I found a chemical that made one of the 3 turn solid. Add F-. When I do that, it's going to precipitate the lead 2+ ions. The other 2 ions, the silver and the thallium, aren't going to precipitate. They're going to remain in solution. What that does is effectively remove the ion from my list. Once a cation is precipitated, it is considered removed. We cross it out of the list. So for my first step, I was trying to find a chemical that made one of the 3 ions turn solid. But now that ion is gone. So for my second step, I'm looking for a chemical across the top of the solubility chart that just makes one of the remaining 2 ions turn solid. Again, hydroxide would be a bad choice. Both of them would precipitate. The iodate and oxalate, the carbonate, phosphate, sulfite, those would all be bad choices. When I look at the SO4 2- column, I see down here in the bottom that silver is specifically listed. Lead's listed too, but the lead is already gone. The silver is specifically listed, but the thallium is not. So that's a good choice. If we add those SO4 2-, add sulfate ions, what that's going to do is to precipitate it's going to get the silver ions. Again, because the silver is specifically listed down here as a chemical that combines with a sulfate to be slightly soluble. It's going to precipitate. And that effectively removes the silver from my list. The first step got one of the three. The second step got one of the remaining two ions, and that just leaves the Tl positive. Now anything is wide open. The other two ions are already gone, so now there's lots of different possibilities for me to choose from. We would have already been looking at this. The right-hand column, hydroxide, will do the trick for us. Add OH minus to precipitate. Here we could have likewise said iodate or oxalate, carbonate. There's lots of choices by the time you get to the third step. Selective precipitation is a style of problem that really has us leaning heavily on the data booklet. Questions start with a mixture of cations, most of the time three ions, so our answers are going to have 3 steps. What we want to do is select a chemical to precipitate out the ions one at a time. And once a chemical is precipitated, we like to cross it off of our list. Our first step, we're looking for one of the 3, cross it off. Then we're looking for a chemical across the top that gets one of the remaining 2. And there's going to be lots of options by the time you get to the third step because the other 2 are already gone. And I hope that helps.